to one and all present here. I, Mrs. Amruta Kantak, on the behalf of AISSMS Polytechnic, welcome all of you in today's session. Let us begin with the first session of Faculty Development Program. The topic for the first session is Introducing the Total Station and Accessories. For this session, we got a very young and devoted expert, Mr.PravinM.Thorat, sir. Good morning, sir. Good morning, sir. He completed the graduation from the Nanded University and master from RSCOE Pune University. Presently, he is working as a HOD for Civil Engineering Department in SRTC FOE College. He has published many technical papers in International Journal of Scientific Research in Engineering and Management. He also shown active participation in many workshops and faculty development programs. Now I request Thorat sir to start the session. Over to you, sir. Hello, I'm audible, sir? Thorat sir. Thorat sir.
Hello.
Thorat sir. Now I
Yes,
request Thorat sir to start the session. Over to you, sir. Hello.
Hello.
Hello, sir.
Am I audible to you, ma'am?
Yes, sir. Yes, sir.
Okay. Thank you. For good and without wasting time, let's start this session today by presenting. Hello. Have you seen the
Yes, sir.
presentation, ma'am? Have you
Yes,
seen the
sir.
presentation? Okay, thank
Yes,
you.
sir.
And my voice is clear to all of you?
Right now your voice is clear, sir.
Thank you so much.
Okay, sir.
So, before starting the session, I will to AISSMS College, principal of the AISSMS College, for giving a chance to an expert lecture for this good session. So, on introduction of total station in the program sponsored by AICT and IICT sponsored refresher program for academic year 2021, organized by AISSMS Polytechnic, Pune. I'm very much thankful to the management body, principals, coordinators, and organizers of these programs for giving me a good opportunity as an expert for this program. Shall we start the session, ma'am?
Yes, sir.
Okay. So before starting the program, I will just told about myself. I'm Professor Pravin.Thorat. Completed my graduation as said by ma'am from AGGS IIT Nanded, and then post graduation by SPPU Pune. Then currently I am working as an in-charge HOD and assistant professor in the college Ramesh Tulsiani Technical Campus, Faculty of Engineering, near to the Kamshet. So today I present here the topic introduction to the total station. We know that nowadays we want the work very faster and we need output as early as possible and very precise. But as compared to the old traditional instruments, we require a lot of times to do the any type of survey works. There should be some mistakes, that should be calculation errors, survey errors, and lot of errors to be found out during surveying. And also, there should be more time required to do any type of surveying. So for reducing time, increasing productivity, we introduced a total station. Total station is nothing but a combination of theodolite, electronic distance measurement. This is electronic setup made in a single unit is known as total station. So in this session, We discuss on the topics given in the list, that is introduction to total station, types of total station, instrumentation, accuracy and precision of total station, then accessories for total station, uses, functions, operation, and applications of total station in the civil engineering industry. Data collect, how to collect the data from the total station. Then we move towards robotic total station, which will be a recent advancement in the total station. That is called as remotely operated total station, or shortly remote robotic total station. So in introduction, we all known about that. The total station is nothing but an electronic or optical instrument used in a modern surveying. The total station is designed for measuring of slant, that is sloping distances, horizontal and vertical angles, and elevation in topographic and geodetic works. Tachymetric survey, as well as for solution of application of geodetic task, the measurement of results can be recorded in the internal memory and transferred to the personal computer by interface. This is the process to take out the readings and transfer to the readings to the computer systems. But this is about the civil engineering. But the use of total station is also in another industries like archaeology, for putting the or taking the record of excavation, in a private accident reconstruction list, and insurance companies to take measurements of scenes. The total station is nothing but it is an electronic theodolite integrated with an electronic distance meter, that is plus internal data storage and our external.
Hello, sir. Hello, sir. सर्कल फिरते तिथे त्यांना काहीच कळत नाही. हॅलो सर. आपण पीपीटी प्रेझेंट करायची म्हणून सांगू त्यांना. थोरात सर, तुमचा आवाज येत नाहीये थोरात सर. थोरात सर, तुमचा आवाज येत नाहीये. हा, आता येतोय सर आवाज.
Okay, just I repeat the session once again.
ओके सर.
The total station is nothing but it is an integrated unit to be built for measuring horizontal distance, slant distance, nothing but a sloping distance, various types of angles, vertical angle, horizontal angle, and a distance from far away. Total station is an electronic theodolite integrated with an electronic distance meter plus internal data storage and external data collector. The total station is designed for measuring
सर
various types of.
एक्सक्यूज मी सर.
हा बोला.
तुमचा कॅमेरा व्यवस्थित नाही होते, टिल्ट झालाय बहुतेक.
अच्छा, टिल्ट झालंय का? मी त्याला ते मोबाईलला काय केलंय, मोबाईलला मी सेट केलंय एका ठिकाणी.
हा, आता बरोबर आहे.
आता बरोबर आहे ते. 2 मिनिटं.
हा, ओके.
येस,
हो,
थँक्यू सर.
ओके.
अजून एक रिक्वेस्ट होती, जर मध्ये कुठं आवाज इंटरप्ट होतील तर प्लीज मला सांगा,
हो,
कारण की कसं आहे,
हो,
मी
हो.
फ्लो मध्ये राहील, बोलत राहील आणि मला कळणार
नाही
नाही.
नाही नाही, सांगणार ना. हो,
ओके सर, थँक्यू सर. The basic properties are unsurpassed range, speed, and accuracy measurement. The total stations are developed to view of the maximum convenience of the work of the user. High efficiency electronic tachometers are intended for the decision. It has the broad audience for solve of the industrial person problems. Angles and distance are measured from the total station to point under survey, and the coordinators like x coordinate, y coordinate, and z coordinate, or northing, easting, and elevations of surveyed points relatively to the total station positions are calculated by using trigonometry and triangulation. Data can be downloaded from the total station to a computer, and application softwares are used to compute results and generate a map of the surveyed area. The several numbers of methods like traverse, triangulations, etc. to be provide these control points during the total station survey. Whatever the methods, the provision of control points include the measurement of two at distance and angles. Again, we know that the distance can be measured by traditional method like by using chain, tape, or various means of measuring. The electronic distance measurement instrument, total station, and GPS. Angle can be measured by using a theodolite. These are the some traditional methods to measure angles, distances, and other things. Once distance and angle measurement is over, computation is performed to provide the control points. A combination of all three results in a powerful instrument called total station. Hence, the total station is an instrument which consists of the some basic parameters like distance measuring unit or instrument. This is called as EDM. Then angle measuring instrument. This is theodolite, and a simple microprocessor. This is the introduction or short introduction about the total station. Now, some of the lines we know that during theodolite survey, we found that the some lines or the magnetic meridians, true meridian, four bearing, back bearing, this type of concept will be studied during measuring the theodolites or measuring the angles by using theodolite. In a total station, we consider the some reference lines like azimuth.
सर तुमचा आवाज येत नाहीये सर. थोरात सर. थोरात सर.
These are all about the various types of reference lines to be provided.
सुरू झालंय.
That is grid north, convergences, true north, azimuth, or true bearing, grid bearings. Or this figure shows about the various reference lines used in the surveying. Now we move towards the various types of total station. Generally, the total stations are classified into two types. First is manual total station, which will be available in the market or which will be used frequently by the surveyors. Or then second one is robotic total station, or it is also called as remotely operated total stations. So first of all, we discuss about the manual total station, which is generally used in the colleges for practices or conducting practicals. So manual total station is nothing but it is an electronic transit theodolite integrated with electronic distance measurement, that is EDM, which will be basically used for measuring the horizontal distance or distance. To measure both the vertical and horizontal angle, this is the inbuilt theodolite to be provided in the total station. From the instrument to a particular point and an onboard a computer to collect calculation. Instrument consists of distance unit, angle measuring instrument, that is theodolite, a simple microprocessor for processing all collected data. It also has a memory card to store the data. Performing the surveying operations, we cannot directly store the data with a computer. We have to store in a specific manner like memory card to be provided with the instrument. It also consists of battery socket which holds the battery, a fully charged battery which will be work for about 3 to 5 hours continuously for doing the any type of project or any type of surveying work. We required minimum 3 to 5 hours for completing the task. Then we move towards the component parts of the total station. Some parts of the total station which will be visible from outside or which will be seen by naked eye. but some parts are inbuilt in the body of the total station. So some of the parts to be shown here, that is handle. The use of handle is to hold the total station properly. Then collimator, the use of collimator or the function of collimator is to bisect approximately. Then telescope, objective focus, eyepiece, horizontal motion screw, vertical motion screw. The video will prepared and will be shown here. To present the video, Safikar, play
ओके
the
ओके
video.
सर, ओके ओके. सिमरन, व्हिडिओ प्रेझेंट कर. होतंय शेअर?
Uh,
Just a minute, sir.
हॅलो.
सर एकच मिनिट फक्त व्हॉइसचं थोडंसं प्रॉब्लेम येतोय. होईल लगेच. एकच मिनिट फक्त.
हॅलो.
हॅलो, बोला सर.
हा बोलतोय.
सर दर्शन बोलतोय कोकणातून. सर आहे का अवेलेबल?
हो कॉलेजला आहे. हा तुम्ही या कॉलेजला या. So we start from the top of the instrument. So this is the handle. This is the handle of the. Good morning. Good morning, all of you. Today we are here to understand the various component parts of total station. So here we present the total station of a made Leica. The name of total station made is Leica TS02 Plus. This is the model name of total station. This is the model total station we have shown here. So today we understand the various component parts of the total station. There are various component parts to be shown here. Some of the component parts visible from direct eyes, some are built inside the instrument. So we are here to identify or to know about the various component parts of the total station. So we start from the top of the instrument. So this is the handle. This is the handle of the instrument. Second, near the handle, we see here one screw. This screw is provided for removing the handle, or in case any adjustment or to be done, or any temporary data to be, or any type of maintenance occurs. This time we can remove this handle for maintenance of this telescope, ocular, or another type of modification. So this handle is provided with screw. Then the third part is here. In some of the instrument, this is, we know that generally in a theodolite there is a vertical frame or U frame to be provided to attach a telescope or a vertical circle. Likewise, in a total station, they provide a frame. You know, or you see here the frame of the total station. This is vertical frame.
Here they provide a vertical circle for measuring vertical angle on this circle. This is vertical circle, and a horizontal circle will be provided inside the machine, or this is electronics vertical or horizontal circle to be provided in this instrument. Then they provide a telescope here. The telescope having object glass to see the object. This is object glass, object lens. You can see also object lens. Then eyepiece or ocular. This eyepiece having focusing knob to focus the object. Then eyepiece adjustment, eyepiece focusing inside or outside to improve the quality of diaphragm for proper bisecting. Then temporary or approximate bisecting knob is provided at the upper side of the telescope for bisecting the object. For perfect bisection we always use telescope, but for approximate bisection we use this knob. This is bisecting knob to be provided at the top side of the telescope. These are the information about telescope, eyepiece and object glass. Then focusing screw. Here one knob is provided. This knob is provided for moving the telescope slowly about its horizontal axis. When we bisect the object, the bisection is approximate bisection is done. When we have to bisect perfectly, that is the diaphragm of the object glass or eyepiece to be provided inside the telescope will match exact the position of the prism or object. We move slowly by using this upper slow motion screw or slow motion screw to be provided for moving the telescope slowly about horizontal axis in a vertical level. This is the function of this vertical axis. Similarly, they provided a horizontal slow motion screw. The horizontal slow motion screw is provided to move the instrument about vertical axis in a horizontal plane. When we bisect the object, we directly bisect by using the telescope, but when we need precise observation, we need accurate readings, we have to bisect perfectly. By using this slow motion screw, we can bisect the object precisely or perfectly. This slow motion screw is useful to move the instrument about vertical axis in a horizontal plane. In a theodolite, which means it's called as swinging of the instrument, or the vertical movement is known as transiting of the telescope. These are the technical terms to be provided in the theodolites. So this is all about the slow motion screw, or it is also called as tangential screw, to be provided for perfect bisection of the object. Then we move towards the battery sections. So here they provide one knob. Rotate this knob, we go towards the battery section. Here they provided a battery. You see here the battery is placed inside this basket. So just keep this bracket and push it inside and turn the knob. We can place the battery to the instrument. So this is the section for battery. Then you see here the display unit. The machine having a display unit with some functions too. Here they provide function 1, function 2, function 3, function 4. 4 types of functions for changing the program. Then escape, when we go to a wrong position, when we back to our original position, we can press escape. Then when we select proper function and we want to work on this, just press function and press enter. So we want the function we want will be started. Then here they provide the function key. This function key having various types of functions to be provided to change or to operate by using functions key. Then cursor arrow, upward, downward, right or left. These are the functions key and display unit. In this total station, they provide this display unit in one side only. But in some type of total station, they provided on another side also. But in this instrument, they provide the one display unit in one side. So this is about the display unit and functions key. Just above the functions key, we see here the leveling tube. This tube is used to level the instrument by using some leveling operations. Leveling operations like by rotating the foot screw. When we rotate this foot screw, this bubble will become in a center. The process, you know how to level the instrument. Just place the instrument parallel to the telescope, rotate the foot screw inside or outside. Then rotate this single foot screw clockwise or anti-clockwise. See where the bubble is centered or not. This type of process will be used while doing a theodolite survey. Similar process to be applied here to level the instrument by using. This is the level for instrument. Now we move downwards. So you can see here the section. This section is known as tri-batch. You see lower plate, upper plate. This section is known as tri-batch. The instrument will be removed from its tri-batch. The knob is provided to remove the instrument from the tri-batch. Just rotate this knob. We can see the instrument will be removed from the tri-batch. This program is provided to shift the another instrument or to fix on this or to change the another instrument on this similar setup. So this is the fixing knob for instrument to be provided on a tri-batch. Here one bubble tube is also provided. This tube is provided to level the tripod stand or tri-batch, because without leveling we cannot do any type of leveling or any type of survey properly. So we have complete proper leveling by using tubes. So first of all, we have to level this bubble tube by using 3/4 foot screw. We have to level the overall instrument. Then after leveling and doing temporary adjustments, all the temporary adjustments, you know about temporary adjustment of the instrument, that is setting, leveling and focusing. So setting means to set the instrument on a tripod stand properly. So in setting, we can set the tripod by using leg adjustment. To level the tripod by using leg adjustment. Then these are the setting operations we done. Then we have to move towards leveling. Leveling is done by using these foot screws. Foot screws clockwise, anti-clockwise or inward, outward. We have to level the instrument. Then focusing is done by using the eyepiece, by just focusing operation to remove the parallax. The knob of eyepiece is just rotate clockwise or anti-clockwise, or to identify proper diaphragm. Just put the white paper in front of the telescope. We see the proper diaphragm on this. These are the temporary adjustment to be done while doing the any type of survey by using total station, theodolite. You just know that total station is nothing a different thing. Total station is just a electronic theodolite. This is nothing but just theodolite having modifications. So in theodolite, we have to do all operations manually or by recording each and every readings and calculating each and every readings. But in a total station, the advantage is that we have to mark or to locate the points and to mark the points or to set the points by using total station. We don't have to calculate any type of data. We don't have to write any type of data, just to be stored inside the machine. So this is the difference between total station and theodolite. Another difference, so another is, this is the total station. Then we move towards some positions here. They provide a knob for import the data from the machine to the computer. This is for importing data from instrument to the computer. Wire to be provided. This type of cable to be provided for connecting the theodolite to the instrument by just placing this knob, and this will be provided or attached to the computer where the software is to be installed. We have to install a software which will be useful for plotting or calculation of survey data. This is the cable to be provided for input or export data to the machine of the instrument. This is all about the component parts of the total station. In some of the total station, they provide a clamping screw at the lower level and at the upper level. The function of the clamping screw is to clamp the instrument at various positions. When we bisect any type of object or we wanted to fix the instrument on this object, just clamp the instrument. So by clamping the instrument will not move from its original position. This is to be done by using vertical clamping screw and lower clamping screw. So some of the instruments they provide horizontal clamping screw and vertical clamping screw.
हॅलो.
हॅलो सर.
हा बोला मॅडम.
हा व्हिडिओ संपलेला आहे, सेशन सुरू केलं.
ओके 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 ठीक. So I hope you all will understand the various components of this. Is the short film which will be recorded to know about the actual component parts of the total station. So just move towards our sessions. We share a PPT. So in this video, we understand the various component parts to be provided to this total station. Some of total station having less component parts to be provided. In some of total station, they provide each and every components part. Handle, I told you in a video, handle securing screw, data input output terminals, instrument height marks. Instrument height marks is provided at this line, at the center of the vertical circle. Then battery cover, optional operation panel, try batch, base plate, leveling foot screw, circular level adjusting screw, circular level display, objective lines, tubular compass slots, optical plummet with practical cover, optical plummet eyepiece, horizontal clamp, horizontal fine motion screw, external power source connector, plate level adjusting screw, vertical clamps, then vertical fine motion screw, telescope eyepiece, telescope focusing ring, peep sight, instrument center mark. These are the various types of components parts to be explained in the videos. Some of the parts to be provided. So as per they modified the total station, they have additional parts to be added in the total. So in this video, we show the Leica TS02 model. This model having less number of component parts to be provided, but the modifications will done. So Leica model will get improved from its Leica 203, then Sokia. These types of or Nikon having the various functions to be provided for the function of surveying. So we move towards the another part of the total session. This is accuracy and precision. As we know that we have to need accurate survey data for plotting, map, or doing any type of calculations. For that, we have to do very precisely and we have to calculate accurately So in a total station, they provide the accuracy depending upon the instrument and various forms of instrument. The first is the angular accuracy varies from 1 second to 20 seconds. The angular accuracy of the total station is varies from 1 second to 20 seconds. Depends on the type of model you have or you can use. The second is distance accuracy depends upon two factors. Number one, instrumental error, which ranges from plus minus 10 mm to plus minus 2 mm. Then error due to the length of measurement. It can be from plus minus 10 mm to plus minus 2 mm per kilometer. But when we use top end model, the error should be minimized. So in a Nikon 1 second total station, the accuracy is 10 to 12 kilometer or 2 ppm. There should be a function of prism while measuring the accuracy of the instrument. When we use single prism, the accuracy will be 2.5 to 2.7 kilometers. When we use two prism, the accuracy will be 5.5 to 7 kilometer. And when we use the prism of type which having three prisms, the accuracy will be increases, that is 5 to 7 kilometers. Precision is the producibility of the measurement, and accuracy is how close the measured position is to the actual location. Measurement of a distance is accomplished with a modulated microwave or infrared carrier signals generated by a small solid state emitter within the instrument's optical path and reflected by a prism reflector or the object under the survey. We say that the total station consists of an EDM. The EDM is nothing but a electronic distance measuring unit which passes the rays or microwave or infrared or carrier signal to the prism. The rays will pass to the prism and reflected within a second to the instrument. The required time and the length will cover. This will be happen to measure the distance in the total station. The modulation pattern in returning signal is read and interrupted by the onboard computer in the total station. The distance is determined by emitting and receiving multiple frequencies and determining the integer number of wavelengths to the target for each frequency. Most of the total station use purpose-built glass poro prism reflector for the EDM signal and can measure distance to few kilometers. Reflector favor total station can that reasonably light in color to a few hundred meters. These are the regarding accuracy and precision of the instrument and prism. Then we move towards various types of accessories to be used in the total station. Generally, we know that the accessories used in the total station is the main part is total station, tripod, prism pole, prism. These are the accessories with approximately more than 14 accessories of different models are available to choose. They are currently in the domain instrument in surveying. The EDM instrument component installed in the total station relatively small but still has distance ranges adequate for most work. Lengths up to 2 km can be measured with a single prism and up to 6 to 7 km with triple prism. The angle resolution of available total station varies from as well as half second for precise instruments suitable for control surveys up to 20 seconds. For instruments made specially for construction stakeouts. Lengths up to about 2 kilometers for. The angle resolution of available total station varies from half second to 20 seconds. This is the accuracy. Then the figure shows or the photo shows the various types of accessories to be used while performing the total station survey or while doing the total station survey. The first is tripod stand, then prism, prism pole. Prism pole is used to fix the prism, then tri-batch, data and power cable. and the battery unit or chargers. So first of all, we know about the total station prism. Most of the total station use purpose-built glass prism reflectors for the EDM signals. A vertical total station can measure distance up to 1,500 meters, that is 490 feet, which an accuracy of about 1.5 millimeters, that is plus minus 2 ppm, that is parts per million. This figure shows the type of prism which will be available in the market. Then move towards prism pole. Prism poles are common tool for land surveying because they can be used to measure elevations and grade through the use of site levels, automatic levels, transit levels, laser levels, total station, etc. It is available in the market with a length of or height of 2.6 meter. These poles are generally manufactured by using good quality raw materials such as brass and aluminum to ensure their durability and strength. These are the main accessories to be used in the total station. So we move towards the various types of use of total station in surveying industry. The first of all, the uses of total station are when 2 points are given. When 2 points are given, we use total station for taking the readings, measuring the distance, measuring the angles, or any other things. Then when only one coordinate is given, in this case, the coordinates of the back stations is determined by any suitable methods. Third one is when no coordinates were given, in which case arbitrary system of coordinates can be used.
Hello, sir.
Elevations and coordinates and display the results on LCD screen. They can also store the data either on board or in an external. This information can be directly stored in an automatic data collector. We know that our instrument having a microprocessor unit, data thereby eliminating the manual recording. So we don't have to record the readings by using a field book or any type of notebooks. So these readings will be recorded directly in the memory card of the instrument provided inside. So because of this, the recording errors will be 100% minimized. These instruments are of tremendous value in all types of surveying. Total stations offer many advantages for almost all types of surveying. They are used for topographic survey, hydrographic survey, cadastral survey, projects, and constructions of the mine survey, engineering survey, roads, railways, or canals, projects, etc. Then we move towards the various functions of the total stations. As we know that in above case, we know about the uses of total station. Then after that, the functions performed by total stations. Total station with their microprocessor can perform a variety of functions and computations depending on how they are programmed. The capabilities vary with the different instruments, but some standards computation includes number one, averaging multiple angle and distance measurement. Second way is correcting electronically measured distance from prism constant, atmospheric pressure, and temperature. We know that the Earth's surface is there should be a curvature. So while doing the total station survey, the total station will minimize the curvature error and atmospheric pressure and temperature also. Making curvature and refraction correction to elevation determined by trigonometric leveling. Reducing slope distances to their horizontal and vertical components. Calculating point elevations from the vertical distance components. Supplemented with keyboards, input of instruments and referential heights. Then computing coordinates of survey points from horizontal angle and horizontal distances. The average multiple angle measurements, second average multiple distance measurement, compute horizontal and vertical distances, correction for temperature, pressure and humidity, then computes inverse, polar and reactions, then compute the coordinates like x coordinate, y coordinates and z coordinates. These are the various functions of the total stations. Then move towards the operations. So in operations of the total station, while using the total station, we have to perform, or we know that when we are doing a total theodolite survey, first of all, we have to do some operations. Likewise, in a total station, the first we have to do these three types of operations like centering, leveling or removal of parallax. Because the total station contains delicate electronic components, they are not as rugged as ordinary theodolite. So we cannot handle with roughly to the total station. They must be picked and transported carefully, handled gently and carefully removed from their case. During removing, we have to pick up we have to take out the total station by picking the handles and remove gently from the case. The setting of total station over the station mark is similar to an ordinary theodolite. This includes centering, leveling, removal of parallax. These are the three activities to be done for maintaining three axes. We know that there are axes provided in the theodolite or total station like vertical axis, horizontal axis and axis of line of collimation, or it is also called as line of sight. We know that the relation between axis of horizontal axis, true neon axis, that is horizontal axis, or line of sight. Line of sight is always perpendicular to the vertical axis or parallel to the horizontal or true neon axis. In this case, to maintain the relationship of the axes properly, we have to do this type of operations like centering of the instrument, leveling and removal of parallax. First of all, we have to set up the tripod by using leg operations. Just similar in theodolite survey, we have doing leg operations by keeping the legs of tripod just on the center of the instrument, or by placing approximately the head of the tripod just on the center of the station. So by leg adjustment, we move the legs inward or outward, or by circumferential actions, or by keeping the knobs of the legs upward and downward for centering approximately over a station. This is a tripod stand. Then the next step is to fix the instrument on the tripod stand by fixing a fixing knob. So care to be taken that when we fix or we set the instrument over a tripod stand, take in mind the fixing knob is properly fixed or not. If the fixing knob is not properly locked, the instrument, the chances of fall of will be more in that case, because of the instrument is in first sentence I again told you the electronic total station is a delicate electronic components. If it will get fall, the overall instrument get disturbed or get, so care should be taken while fixing the instrument over a tripod stand. Then we have to do the leveling operation and centering of the instrument. The centering of the instrument is done by using optical plummet to be provided to the instrument. and by using or by laser provided in the instrument. There are two types of centering to be done by using total station, by using eye estimation, by looking through the optical plummet to the instrument to the total station, and by providing the or by emitting the laser to the instrument. So while centering, we have to move the legs of the tripod inward, outward, or by using the knob of the tripod upward and outward, by placing the position of the legs of the tripod up and down, by removing or tightening the knob provided at the tripod legs. The centering is done. After that, we have to level the instrument by using leveling operation. The leveling operation is done by using 3-foot screw provided at the tri-patch. While leveling, we have to keep the telescope parallel to the 2-foot screw and then rotate the foot screw inward or outward, up to which the central bubble of the spirit level comes in a center. Then this process is also seen on the screen of the total station, or we also seen directly in the spirit level provided on the horizontal circle or top of the horizontal circle or near the functions key. So leveling operation will be done. Then we have to do third operation, that is removal of parallax. Removal of parallax can be done by the operation of rotating the eyepiece knob clockwise or anti-clockwise to find the clear image of the object. So we have to remove these 3 actions to be done while doing any type of total station survey. Total stations are controlled with entries made either their built-in keyboards or through the keyboards of handheld data collectors. Details for operating each individual total stations varies somewhat and therefore are not described. The accuracy achieved with the total station is mainly depends upon on operator procedure of the carefully centering and leveling of the instrument. So we have to do or we have to perform these 3 actions very carefully for doing accurate survey work. In this case, we have to do accurate pointing at targets, then taking average of multiple angle measurements made in both and traverse positions, then peripheral equipment that can affect the accuracy includes tri-batches, optical plummets, prism poles. The care should be taken while doing the operation. The tri-batch, optical plummets, prism and prism should be at its position while doing the survey. They will not move. When we are fixing the objects or marking the points, prism pole and prism should be at its position. It should not be disturbed from any type of means. Tri-batches must provide and sunk fit without slippage. So in video I show that one knob is provided at the tri-batch for fixing the instrument and tri-batch for perfectly fixing the instrument over that. So tri-batch must be provided a sunk fit without slippage. The instrument will not get slip or the tri-batch will not get slip because of any type of action performed by operator. Optical plummets that are not of adjustment cause instrument to be set up over the measurement point. The prism pole should be perfectly vertical and prism should be well fitted on that. Sometimes we know that the prism of the will not fix on the prism pole. It will move here and there. So the care should be taken that the prism should be well fitted on the prism pole. The prism should be checked frequently to determine their constants. These are the some various operations to be done before doing any type of survey work. Some type of survey work to be done by using total stations are mentioned here. So first is remote elevation measurement. We know that by using theodolite, we can measure vertical angle, horizontal angle. By using tachometry, we find sloping this, we find a horizontal distance. But by using total station, we also find the remote elevations where we cannot reach at this position. So first is remote elevation measurement. In figure, we see that the total station is fixed at a station point and the object is placed at a far distance away from the total station. This is the provided. So we have to find out the height of the tower. So this process of finding the height of the objects without actually going to the top of the objects is known as remote elevation measurement. But sometimes by using traditional instruments, we have to go the top of the instrument and we have not reached properly, so we cannot find. At this time, we can approximately take the height of the instrument. But in total, there should be no need to go at the remote locations. By using total station, we can find out the remote elevation also. That is, a total station placed remotely far away from the objects is used to measure the heights. This is all about remote elevation measurement by using total station. Then remote distance measurement is known as RDM or missing line measurement. So the process of finding the distance between 2 points, that is object A and object B, which are not intervisible from each other. So some cases we have studied in the basic surveying the various obstacles in the surveying. So this type of obstacles when occurs during the surveying, the total station which easily use and tackle these obstacles. The process of finding the distance between objects A and B which are not intervisible from each other from another point is known as remote distance measurement. This method is very useful for finding distance between 2 points which has an obstruction between them. It is of 2 types. There are 2 types of obstruction, that is continuous and radial measurements. The figure shows the continuous and radial measurements by using total station. Distance can be obtained either in the continuous mode, that is by measuring the line AB, BC, CD, DE, EF, etc. etc. Or in the radial mode like AB, BC, CD up to n number of points. However, the field procedure is same for both. The selection of operation is variable. This is required when there are obstructions in between the survey lines. Then we move towards fixing of missing pillars or setting out or stake out. The process of fixing missing pillars on the ground using theoretical coordinates is known as stakeout. Generally, it is known as stakeout. Here, 2 other known coordinates are required. Number 1, process of finding the positions of known coordinates point, for example, missing boundary pillars. In this figure, they show the station set up at instrument station, missing pillar and back station. Then we have to do resection by using total station. The process of finding the coordinates of the instrument, positioning, making use of other control points known as resection. This method we use in plane table surveying, that is resection method by using plane table. This function is also done by total station. Then calculation of area. Area can be calculated by any figure just by giving the coordinates of the corner of the figure. We can calculate the area and by finding the area of any closed figures. This is all about the survey to be done by using total stations. Then we move towards the applications of total station. There are many applications of total stations. There are many other facilities available. The total station can be used for the following purposes: for detailed survey, that is data collection, like contouring, road profiling, etc., etc. Then control survey, that is traversing, height measurement, which consists of remote elevation measurement, where the remote areas to be surveyed by using total station. Then fixing of missing pillars or setting out stakeout, measurement, etc., etc. Data collection. Measurements can be stored on board with all the total stations. The two options that are available are: data can be stored directly in the memory of the microcomputer and later downloaded to an external storage device via RS-232 connection. This is the name of this cable shown in the video or explained in the video. The second option is the removable memory card. When the one card is full, it can be removed and another card can be quickly installed. This is the method to take out or collect data to be surveyed. This is the information regarding the total stations or manually operated total station. So in a second slide, we have discussed about the types of total station. So up to that, we covered the data regarding manual operated total station. Now we move towards the second type of total station. This is nothing but remotely operated total station, or it is also called as a robotic total station. So as name indicate, there should be a robot is provided. So we know that while doing the manual total station survey, we need two persons for taking the readings and for holding the prism pole. But in a robotic survey, there is no need to operate the total station. So we can save the time as well as man force required to do the survey. In remotely operated total station, the instrument will operated by a operating device which is in the hand of operator, or which is directly operated from the office also by having Wi-Fi connectivity or Bluetooth connectivity. The robotic total station, which is simple concept. A robotic total station is a total station that allows remote operations where we cannot do the survey by using manual total station. This means you only need one operator and can perform far more calculations and inspections in a less time than with a traditional total station. Remotely operated total stations are a rare expectation to this dilemma. The robotic total station can provide impactful benefits with minimal fuss. It is also a straightforward technology with a clear path to implementation. Here are just a few of benefits. Number one, more accurate measurements, greater productivity, fewer mistakes, reduce rework, better quality assurance. When we do the survey by using robotic total station, the accuracy will automatically increase because the total station is operated automatically. Then we have a greater productivity because of less manpower, less time required. We do various types of survey within a less time. So we have greater productivity with robotic total station. Then mistakes, or we know that errors to be minimized by using robotic total station. The chances of rework should be very less. And we have the better quality assurance. By using robotic total station, the quality is more precise than manually operated total station. The remote positioning unit enables control of a total station instrument from a distance. Robotic total stations allow the operator to control the instrument from a distance via remote control. Robotic systems offer reflector-less measurement superior to any other instruments available in the market. Capable of precision measurements, this technology has tremendous benefits for every user. This eliminates the need for an assistant staff member as the operator holds the reflector and controls the total station from the observed points. The remote positioning unit, which is attached to a prism pole, has a built-in telemetry link for communication with the total station. Even a prism is not needed near the total station. The total station automatically moves and locate the target. A person required at the target at different survey locations. The robotic total stations speed up the survey work and reduce the manpower. Robotic total station is the faster motors available in a 1, 3, and 5 second angles accuracy. The accuracy of the robotic total station is 1 second, 3 seconds, and 5 seconds. Angle accuracy, you can select the instrument that benefits or that fits your requirements. This is all about the robotic total station, the various types of robotic total station which is available in the market for doing various types of total station survey, for laying the layout of any type of building, for fixing the position of columns, for calculating area of the any site, or by calculating the various angles from the remotely located areas where manually operation will not be done. So some features to be included in a robotic total station which are innovative and completely cable-free system design. The robotic total station is completely cable-free system design, which consists of Wi-Fi or Bluetooth connection to be provided some of the robotic total station. New RC3 with superior extract quick lock tracking technology to be used in the robotic total stations for locking the instrument at the suitable object or suitable point. The most advanced and longest range, the most powerful reflector-less technology available in robotic total station. Full color graphical windows, mobile instrument, and field control interference to be provided with robotic total station. The total station is lighter in weight than the competition. Some total station, we know that the weight of the total station near about 5 to 6 kg. But some robotic total stations are lighter in weight. Then some of the benefits of robotic total stations are shared here. Number 1, field productivity. Before doing any type of work, we have to achieve a productability of any type of survey works or any type of product work to be needed. So field productivity consists of while using the robotic total station. This is benefits of the robotic total station. Number 1 is field productivity. Field productivity in the view of faster and more accurate layouts. While using the robotic total station, we have to do very accurate layout, and the time will required is very less. Faster and more accurate quality checks. The checks should be provided very accurately by using robotic total station. Then quality of work is very good. The quality, greater accuracy, increased number of inspection points, reduce errors and rework. We know that while doing the total station survey or manual total station, we have to collect each and every data from the each and every locations. We have to manually rotate the total station from first, second, and n number of points. And likewise, the prism operator should also rotate from its position to position. In that case, some points will be missed. But in a robotic torsion, this type of error should not be happen, because the total station, robotic total station, is firstly rotate in a 360 degree to find out the obstacles to be in the present in the site where we have to do survey with a great accuracy, increase number of inspection points. It will inspect various number of points itself without a operator. Then reduce error and rework. Then more efficient office to field communication. Real-time data accessibility. In robotic total station survey, we can access the data as on while doing the survey work with greater accuracy. But in a manual total station survey, first we have to do total station survey, then it will be stored in the memory card, and then the output is given to the computer. Then and then we can access the data from the manual total station. But in robotic total station, the real-time data accessibility is present by using Wi-Fi or Bluetooth connectivity. Then improve handover as a built data and faster completion. By using robotic total session, we hand over the data of surveyed as a built data with some calculations and precision, faster completion of the work. This figure shows the precast parking deck with robotic total session. In this photo, we have see there an operator with a operating device and a prism. So this will be operate from the point to point to the total station. This is the example photograph to be shared here. We can provide the, or we can use the robotic total station by cast or bridge construction for providing a layout to the building or multi-story building. A bigger. Some features of total stations are stated here. Number one, the feature is range. Suppose we know that while doing total, we have to access the range. So first of all, the first feature robotic total station is range. Distance you can validate with accuracy. So where it is required or what we need to know, infrastructure projects usually require a longer range. While doing a road survey or railway survey or canal survey, we have to survey to a longer distance. So in this project, we usually require a longer range of theodolite or instrument. Vertical construction projects often need only a shorter range. In another project like high-rise buildings, in this case, we do not need high range, but we need a vertical control. Considering the average and maximum distance between your known control point and the points that you are laying out or validating. This is the features regarding range. Then the view of accuracy. We have accurate survey data, level of precision. Detailed applications usually require a higher level of precision while doing the survey. Consider the average and minimum acceptable variations in specifications for your application. As the range of model increases or higher range model or top end model we use, the features also get improved or the functions also get improved. So likewise, when we use mobile, some basic mobile have lesser functions. Then when we increase or we provide a top end mobile, the functions of the mobile will get also increases. Likewise, in a total station, when we purchase or when we take out or we use total stations of variety of ranges available in the market like Nokia, Leica, Nikon, etc., etc. So As the variety of total station use, likewise the functions and operations and other features will be improved as the model of instrument will get at its top end or higher end. Accuracy by means of level of precision. Detailed applications usually required a higher level of precision. Consider the average and minimum acceptable variations in specifications for your applications. Then next feature is sensor stability. The sensor stability is nothing but the ability to maintain lock. Better quality, ability to maintain lock, reduce disruptions and improves productivity. So we know that the functions of sensor by using, so we know that we are all using a sensor based mobile by using finger key sensors to lock or unlock the mobile phones. Likewise, this feature is also provided in the robotic total station. Then time to acquisition. The time to acquisition is how long it takes to set up and finish the prism. So we know that before doing any type of survey work, we have to do some necessary actions or operations like centering, leveling, and removal of paraflags. This is the feature will be improved here. How long it takes the setup and find the prism. In robotic total station, the total station will automatically find out the position of prism. Faster times improves overall productivity. So we know that while doing the survey work, more time or initial time, that is half an hour or 15 to 20 minutes, or when operator is skillful, minimum 15 minutes to be required for setting up the total session or for identifying the position of prism. But in a robot, setup and finding the prism. Then battery life. The battery life, how long battery lasts between charges. This is also required while considering the total station survey. We know that in manual total station we say that the battery is used up to consider how many hours per day your RTS will be in the service. Generally, it works up to 5 to 6 hours. So, in manual survey, they provide generally two batteries. One is inside the instrument and one is standby. Then ease of setup and compatibility with design softwares. So we know that, or we say that the total station survey, the data to be produced to the computer or various types of softwares for accessibility and for making maps or for any type of calculation. Complexity of the process from purchase to use of the product. Likewise, when we use the Leica company total station, some softwares will not get matched with this application. So these are the complexity of the process from purchase to the willing to switch. By considering the amount of time your team has available to invest in the setup, positions, or it will match with any types of extracting or for map making or for calculations of the total station is inbuilt with Wi-Fi connectivity or Bluetooth. So in the view of communication range, distance you can transmit the data. Some remote operated total stations require reliable access to Wi-Fi, which may not always be feasible on your job site. In those situations, having a remote operated total station can leverage Bluetooth communication is helpful. We know that sometimes Wi-Fi connectivity is not proper in this case, so we use Bluetooth connectivity at such a conditions or situations will happen during the survey. Then we move towards the main and important part of the robotic total, that is price or cost or warranty. Price, warranty, and supports. Because we know that when we purchase any type of product, we have to easily available accessories with themselves. So there should be no headache to us. Accessories required for price, warranty, and supports. A solid warranty implies manufacturer willing to stand behind their project. Expect quality supports for any type of maintenance. Station. This figure shows the robot station is used in various means. Number one, feasibility design planning. So when we have to design some or planning some structural work, the feasibility in design and planning, survey and documents existing conditions for analysis. While using the robotic total station, we can maintain all the data and we can use or we can use operate this by remotely, and the calculations done automatically, survey and documents existing conditions for analysis works. Then the layout, staybacks, format, then quality assurance, verify work in place, perform surface analysis. Then at construction handovers, documents as built conditions to be provided to the responsible persons to hand over the jobs. So we know that before any type of construction or any type of engineering project, first of all, we have to do various types of survey. So in various types of survey, we can use manual total station and robotic total station as well. So this session will helpful to understand the various component parts of manual total station, robotic total station, and the processes to be carried out by using total stations, and the survey work to be done prior to the construction work. So I hope this is the small presentation we have present here to understand the various component parts, processes, operations done by total station, functions, applications, uses, and various types of accessories, and accuracy and precision of the total station. I hope you guys all have understand the concepts present over here. So do you have any doubt? Just feel free to ask regarding the introduction to total station. So this is
Any question from the participants? Sir, there is one question. Hello?
Yes, ma'am. Yes, ma'am.
What is the difference between true north and grid north?
Okay. I will post this answer on the chat box also. The grid north is an navigational term referring to the direction northwards along the grid lines. But in contrast with a true north and direction to the North Pole and magnetic north. So while doing the total station or while using the total station or robotic total station, we use or we consider the curvature of Earth. So in that case, we have to consider the navigational terms. So the angle which is calculated from the true north or magnetic north or grid north will be accurate. by considering curvature and any other navigational terms. Azimuth is nothing but we have. हॅलो
हॅलो सर.
आवाज येतोय मॅडम माझा माझा की
हो
इंटरप्ट
हो.
होत आहे?
नाही नाही, आवाज येतो सर.
हा कारण की काय झालं माहितीये का, लॅपटॉप मध्ये मी लावलेला आहे ना, तर मला थोडा तो असा इंटरप्ट झालेला वाटलाय, म्हणून मी थोडं विचारलं तुम्हाला.
नाही नाही, येतो सर आवाज.
Okay, thank you. So next question, what is azimuth? Azimuth is nothing other. It is an angle measured with a true north. That is the topmost by using a vertical line of the or just figure shared with you in a slide share. Just sharing the slide here. ह्या फिगर मध्ये आपल्याला ते क्लिअर होईल. ग्रीड नॉर्थ म्हणजे काय, अँगल कसा आपण घेतो, किंवा अझ्युम्यूथ म्हणजे काय, किंवा अझ्युम्यूथ और ट्रू बेरिंग म्हणजे काय, ते आपण कुठून घ्यायचंय, ह्या फिगर मध्ये आपल्याला ते क्लिअर होईल. याच्यामध्ये आपण म्हटलेलंच आहे, azimuth of any survey line or a traverse leg is the clockwise angle from the true north. It can be calculated by astronomical observations. Any other question?
No sir.
Okay.
On the behalf of our institute, I mention my words of thanks to Thorat sir for giving us their valuable time and share the concept of total station. Definitely, sir, your knowledge will be helpful in teaching learning process. Thank you, sir. Thank you very much. Have a nice day to you, sir.
Thank you, madam. This is the short session to be conducted here, and try to improve myself, because I just know my checks, and from this session I will also improve myself for better, and we provide good knowledge to the listeners also. Thank you so much for giving me opportunity to present over here. Thank you in behalf of SRTTC, and I also thank you to the management body of the AISSMS Polytechnic and the coordinators, Sapekar sir, Gauri madam. Thank you so much, madam.
Thank you, sir.
Thank you, sir. All the participants are requested to fill the attendance. The link is available in a chat box.